So we had a lot of learning just happen. This example is going to slow that down a little bit. Example 3. To the right is an xt graph of the motion of a particle. Rank the values of the particle's x velocity, like the position velocity, vx at points p, q, r, and s from most positive to most negative. So what you need to do is you want to draw the slope of that blue curve at p, the slope of the blue curve at Q, the tangent line is a better word to use, slope at R and slope at S. So what I need you to do, guys, is look at P. If you drew a tangent line so that it touches the graph just barely touching, you're going to draw one like that, right? That's your slope at point P. Okay, now let's draw a slope that touches just once at Q. There you go. Now at R, this one's going downhill, isn't it? It almost matches the graph identical, but the graph will start to come back. And then at S. Okay, so let's take a look, and it says, part A, rank the values of the particle's velocity from the most positive to the most negative. So what I want you to see is that P is going uphill, Q is going nowhere, R is going downhill, negative, and S is also going nowhere. So from the most positive, well, that would be point P. And then Q and S are interchangeable because they're both 0. And then R goes downhill. Part B, at which point is it positive? Well, the only positive slope I see is point P. C, at which point is it negative? The only thing I see negative is R. Part D, at what point is it 0? Okay, so they like flatten out. In other words, they're changing direction. When you change direction, your velocity actually goes to 0. So that would be at point Q and at point S. Now part E, rank the values of the particle's speed. So what you need to do is, this is the absolute value thing. It's simply asking about the steepness. It's not asking about plus versus minus. It's just asking, oh, that looks like it's just asking for the most steep line. So when I look at this graph and I look at P and R, clearly Q and S are 0. So they're going to be at the tail ends, okay? So the value of that is Q and S are 0. Put them at the end. Which slope is more steep? Does it look like P is more steep uphill or that R is more steep downhill? To me, R is more steep. So the absolute value of its slope would be bigger than the absolute value of P, because R is more steep, even though it's going downhill, than P is. That finishes that. Example 4. I think it's important, especially for those of you who have never done calculus. Let's talk about this instantaneous volume. So this is a position equation, right? In other words, the position is constantly changing. Look, it's an equation. The position is 3 times time minus 3 times time squared. So it all depends on time, and it's probably, if you graphed that, and dare I say, like, you should. So I mean, you can fast forward this part of the video. Go ahead if you want, but I'm telling you, I think this would be worth you seeing. If I graph it, what is it? 3t minus 3t squared. Okay, you guys can see it's a parabola, so the position is constantly changing. You guys can see that here, I hope. Okay? It's not, in other words, it's not like a straight line or anything. It's not standing still. What is the velocity? Instantaneous velocity, we need to do the derivative. Derivative of position. Please memorize that. It's huge. So we're going to have velocity equals, it's not 3t minus 3t squared. I need to change it. Are you ready? Watch carefully. This has an exponent of 1. Multiply it with that 3. Its exponent goes down by 1. Take this exponent, multiply it by 3, or negative 3. Its exponent goes down by 1. So this is no longer my equation, because that's just my position equation. This is my velocity equation. Simplified is 3t to the 0 power. Well, that's silly. That's just 1. Minus 6t to the first power, which again, we don't need that. So velocity is 3 minus 6t. And they're asking what is the velocity at 0.25 seconds, 0.5 seconds, and 1 second. So here I go. Velocity at 0.25 seconds is 3 minus 6 times 0.25. Do I have that done? Let me see if I have it done. I did not. I added this problem. So while I should be able to do that, I'm just verifying. I think I should probably verify in a calculator. 1.5. That's instantaneous. And now my velocity at, what do they have next? 0.5 seconds is 3 minus 6 times 0.5. So 0. So he must be turning around or something, huh? That would make sense. Look at the graph. Look at that. Absolutely. And you can see that at half a second. It's like, I wish I could, oh, right there. Look, isn't that cool? That's exactly right. He's turning around there. And velocity at 1 second. So 3 minus 6 times 1 is, look at that, negative 3 meters per second. And that totally makes sense according to this graph, because at 1, it would be going downhill, like the graph does, which is kind of cool to see. And it says, what is the speed at these times? So the speed at 0.25 seconds is the absolute value, so 1.5 meters per second. The speed at 0.5 seconds is the absolute value, so 0 meters per second. And the speed at 1 second is 3 meters per second. Remember, they're absolute values. And look at that video. I know there's a beautiful video. To be honest with you, it's time for me to leave, so I'm not going to watch it.
Okay, Andrew, this is for
He
you.
does
We are
do a neat job explaining there. And this is just again for me to say, hopefully can you zoom in there? Look at that. So here, like at this exact moment in time, right here, you can see we would have a positive speed, a 0 speed, and a negative speed. Over here, we would have a constant velocity. See how it's like just a straight line the whole way through? Our velocity would be constant. Like it's not like, oh, the velocity's 2, now it's 5, now it's 7, now it's 0. That doesn't happen there. And then here, oh, we got a lot of velocities happening, right? So here, this is a constant velocity here. This is a constant negative velocity. Here we got like a change happening, right? And so it probably is 0 velocity because we're turning around. And here we have a constant positive velocity. So it's really important for you to be able to read graphs. Again, I have things that I have looked at I would suggest looking at. I don't put them on there for my reference anymore. I put them on there because I had to watch those videos to understand this lesson fully. All right, guys, have a wonderful night.